Okay, so I want to first go over quickly the 5 rules that we're going to be talking about before I start doing the example problems. So, rule number 1 is when you multiply two things with the same base, you add the exponent, but you don't change the base. This is really important. The base stays the same, but you add the exponents. Again, you can watch the other previous video on exponent rules to see the proof of these different formulas, but I just want to refresh your memory on what they are. The second formula is when you divide two numbers with the same base, you subtract the exponents, the top one minus the bottom one. But again, you do not change the base. Always keep the base the same when you're using exponent rules, only change the exponents. Okay, the third rule is if you have a power of a power, you keep the base the same, but you multiply the two powers together to get the new power. Fourth rule is negative exponents. Anytime you have a negative exponent, it actually means you're dividing that many times instead of multiplying that many times. So you have to, if it's in the numerator, division means put it into the denominator. So any exponent with a negative value in the numerator should be moved into the denominator, and then you just change the sign to positive when you move it down. Or if it's already in the denominator, you know that dividing by a fraction is the same as multiplying by the reciprocal. So if you're already in the denominator, then you should move it into the numerator, and again change the negative from a positive. You move both the base and the exponent into the numerator. You don't change the value, the numerical value of either one. All you do is change the negative to the positive when you move it up. Or if you're going to move it from the numerator to the denominator, just change the negative to a positive and move the whole thing down. And this right here should kind of correlate to this rule number 2. See, this one in the denominator right here, x to the b, if you moved it up into the numerator, you'd have to change the sign from b to negative b. So if you moved x to the b up to the numerator, it would be x to the negative b, and then you can see x to the a and x to the negative b is x to the a plus a negative b is the same as a minus b. So this rule right here and this rule right here, they kind of go together. Negative exponents means in the denominator, or subtract means in the denominator. Finally, anything to the 0 power is 1, except 0 to the 0 is undefined. But when you have variables or numerical values, anything except 0 raised to the 0 power will always equal 1. Okay, let's go and start some practice problems. Okay, I've got 5 problems that I'm going to do, and we're going to solve them using MS Paint, and I'll try to talk you through them. So here we go. Number 1. We've got x to the 4th times y to the 6th divided by xy to the 3rd power. So when you're simplifying these expressions, or reducing them to their lowest terms, you need to follow Pemdas as you always would. So in the numerator, there's no parentheses, but in the denominator I have parentheses. So I'm going to deal with these parentheses and this exponent very first. So my numerator, I'm going to keep it as x to the 4th, y to the 6th, and then in the denominator, I'm going to use the power of a power rule. This x and this y are both raised to the 1st power right now. So when I distribute that 3rd power in, I'm going to get x to the 3rd and y to the 3rd. Okay? It's because I have x, y happening 3 times. So I've got x happening 3 times, and I've got y happening 3 times. Now I can use the rule of division, and you always want to just look at one variable at a time. So here I'm just looking at my x's. X to the 4th divided by x to the 3rd. When you divide two things with the same base, you subtract the exponents. So 4 minus 3 is 1. So I have x to the 1st power. Now I'm going to look at my y's. Y to the 6th divided by y to the 3rd. You subtract the exponents and you get y to the 3rd. And that's my final answer. Okay, so I want to reiterate the importance that you just go one variable at a time. You never mix your x and your y. So just look at one variable and then the other. Alright, next problem. Again, I've got power of a power in the denominator and no power of a power in the numerator. So I'm just going to rewrite the numerator. I'm not messing with that yet. X to the 3rd times x squared. In the denominator here, I've got a power of a power. So this x right here, there's only one of them, but this whole expression is happening 3 times. That's what the exponent on the outside means. So I'm going to have x to the 3rd power. Okay, now I've got y to the 4th, and that's happening 3 times. So I'm going to have y to the 4th times y to the 4th times y to the 4th for a grand total of y to the 12th. Again, the shortcut is you multiply the two exponents together. Okay, now I can simplify. You want to look at everything with an x in it. Okay, so those all have an x in them. So in the numerator, I've got x to the 5th, because I multiply these two together. I have x cubed times x squared is x to the 5th, but I'm dividing by x cubed. So 5 in the top, 3 in the bottom, means I'm going to have 2 left in the top. Alternatively, you can look at just these two and think, okay, these two cancel out, leaving me with x squared in the numerator. So both ways to think about it work. In the denominator, there's nothing else with y's in it, So there's no way to reduce this y to the 12th. It's just y to the 12th, and there's my answer. Okay, let's keep going. To number 3. Okay, looking at number 3, we've now got a's and b's instead of x's and y's, and we also have some numerical values. So treat the numbers just like you would any other variable. The numbers in the front you're going to deal with first. What is 6 divided by 2? 6 divided by 2 is 3. Since they don't have any exponents on them, I'm not using any rules of exponents, I'm using simple division. If this would have been 6 to some power and 2 to some power, I could not have combined them because they didn't have the same base. But since they don't have any exponents, I can combine them using regular division. Okay, now I've got a cubed and b to the 4th. So I'm just going to rewrite those. A cubed, b to the 4th. Now in the denominator, again, power of a power. This is a cubed, b cubed. Because each of these guys inside the parentheses is to the first power. Anytime it doesn't say what power it is, it's not shown, then it's automatically to the first power. Okay, now I can reduce. I've got a 3. It's the only number, so that's easy. For my a's, I've got a cubed over a cubed. If you want to follow the rule, it would be a to the 3rd, so 3 minus 3, which is 0, and anything to the 0 power is 1. Or you could just realize that anything divided by itself is 1, so those cancel out. And then I've got b to the 4th over b to the 3rd. Subtract the exponents, or think about it as a combat. You got 4 guys in the top, 3 guys in the bottom. The top will win by 1. And what kind of a guy is it? It's a b, so 3b is left over. Denominator is a 1, but you don't have to write it. Number 4. Okay, here's number 4. Now, I've got a 5 and a 3, but see this 3, it's in parentheses. So I cannot divide 5 by 3 here because I have to follow Pemdas. These parentheses with this exponent are going to come first. So let me rewrite the numerator here. I've got 5x to the 4th, y to the 6th. Okay, now look at this parentheses and see that it has a negative exponent. Remember, a negative exponent means if it's in the denominator, it should be moved into the numerator because it means divide instead of multiply, essentially. So if you're dividing something in the denominator, you should move it to the numerator and multiply. So this whole expression, this entire thing, is getting moved into the numerator. So this whole expression is 3xy, and it was to the negative power in the denominator. So when I move it to the numerator, it becomes a positive 2. Okay? Now, I can actually distribute the 2 inside. So this 3 right here is getting raised to the 2nd power. First let me copy down the same stuff here. So that's going to be 5x to the 4th, y to the 6th. Okay. Now let me distribute this guy in here, here, and here. So that's going to be times 3 squared, x to the 2nd power is x squared, and y squared. Okay. Now I can combine like terms. Okay, numerically, I have a 5 and a 3 squared. Well, let's just write this 3 squared as a 9, and 5 times 9 is 45. So again, the numbers we're just doing as regular numbers. Now my variables, I've got x to the 4th right here, and I've got x squared right here, so I have a total of x to the 6th. Again, you multiply two numbers with the same base, you should add the exponents. For the y's, how many y's do I have? I have 6 here and 2 here, so I have a total of 8. So my final answer is 45, x to the 6th, y to the 8th. Notice that everything is in the numerator, because in the original problem, a negative exponent in the bottom means I had to move everything into the numerator. Okay, very last one here, number 5. X to the negative 4th, y to the 6th, xy to the negative 3rd over 3. So let me draw my fraction bar. Now this x to the negative 4th, well, technically I should do this stuff first, because this is my parentheses and my exponent. So let's do that first. This x right here is raised to the 3rd power, so I've got x to the 3rd power. This y to the negative 3rd, remember when you have a power of a power, you multiply them, so this is going to be y to the negative 9th. Okay, and in the numerator I had x to the negative 4th and y to the 6th. Okay, now what I like to do next is anytime I have a negative exponent, I like to move it to its proper place. You could simply use the rule of exponents and say that this is going to be x to the negative 4 minus 3, because these are divided, so negative 4 minus 3 is x to the negative 7th. But conceptually, for me, it's easier to think about this guy. Because his exponent is negative, he's in the wrong spot. I need to move him into the bottom, okay? So if I have x to the third already here, and then I move x to the fourth down there, I'm going to have a grand total of x to the 7th, all in the denominator. Now let's look at these guys. I need to take this guy, and I need to move him up here. Okay, when I move him up, he changes exponent from negative 9 to positive 9. So I already had 6 y's up here, and now I'm moving 9 more up, so I have a total of 15 in the numerator, and that's my final answer. Again, if you wanted to just blindly follow the rules of exponents, you could do the fact that these are divided, so you subtract the exponents. 6 minus a negative 9 is positive 15, and that, of course, gives you the same answer. Okay? So remember, when you're solving simplifying, not solving, when you're simplifying these kind of complex exponent problems that have multiple variables, parentheses, powers of powers, and negative exponents, you want to be really methodical. You definitely have to follow Pemdas, so the first thing to do is distribute anything with parentheses and an exponent, distribute that exponent inside. The second step I generally do is take care of anything with a negative exponent. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. And then finally, combine like terms, numbers with numbers, and then variables with the same variables until you get everything down to just 1 y to some power, 1 x to some power, and 1 number. Okay?